Hi students, welcome to Math4U. Today in this session we are going to discuss about the geometric meaning of zeros of a polynomial. This is from grade 10, chapter 2, Polynomials. So geometric meaning of a polynomial. Today we are going to discuss about different types, okay, that is linear, quadratic and cubic polynomial. How can we understand from the graph how many zeros are there for this polynomial, okay? This is the topic. So let's check for linear polynomial. You can see here one linear polynomial I have written 2x plus 3. So y is equal to 2x plus 3. That means we can say that the polynomial p of x is equal to 2x plus 3, and from the degree you can say that this is a linear polynomial, right? So when we put the values, you can see here for x we have put it minus 2. So let's see what is p of minus 2. That is equal to 2 into minus 2 plus 3. So minus 4 plus 3 is equal to minus 1. That is the value you got for y here or for the polynomial. So same, when we put p of 2, you will get 7 as the answer. And we have plotted here. This is I have taken from your textbook only. So you can see here the graph have plotted negative 2, 1. Oh, okay, sorry, negative 2, negative 1. Yeah, you can see here negative 2, negative 1 and 2, 7. Yeah, here. And we got a straight line. You know that for linear polynomial, we get a straight line. And how can we understand how many zeros are there? Okay, so look at this. You have to check where the line, the graph, this y is equal to 2x plus 3 met x-axis. So where it met, you can see here it met at negative 3 by 2, 0. See here, negative 3 by 2, 0. So it met at negative 3 by 2 and 0. How can we identify then from this? Yes, let's check it. But let's put instead of x, negative 3 by 2. Okay, negative 3 by 2 is equal to 2 into negative 3 by 2 plus 3, right? So we are cancelling these two. That is equal to negative 3 plus 3 is equal to 0. So when we put the value of x as negative 3 by 2, we got the polynomial y is equal to 0. So we can say that negative 3 by 2 is the 0 of this polynomial, right? And you can understand that from the figure itself, I mean the graph. So this is how you can understand. Therefore, the linear polynomial ax plus b, where a is equal to 0, has exactly 1 0. That means the zeros of this linear polynomial will be only 1. Okay. So let's see about what is the situation case of quadratic polynomial. So consider this quadratic polynomial, that is x square minus 3x minus 4. The polynomial p of x is equal to this one. So that let's check. Here you can see when we put the x value as minus 2, minus 1, 0, 1, 2, 3, 4, 5, what will be the y value or what will be the value of the p of x. Okay, so you can see here from the graph. Let's see from the graph first. You can see in this graph wherever it meets at x-axis. So after plotting this, you can see for a quadratic equation, you will get a parabola either opening upward or opening downward. Okay. So in this case, you can see negative 2, 6, we have marked all these points have marked in this graph, and we got a parabola which is opening upward. And the next step is to check where the graph, the parabola meets at the x-axis. Okay, that is what you know, this is the x-axis, and in this x-axis where it is meeting. So you can see here it's meeting at negative 1 0. Next it is going like this and meeting here at 4 0. So the x is equal to x minus 1 and 4. So let's see where when we put the x value as minus 1 and 4, whether we are getting p of x as 0. So p of x is equal to x square minus 3x minus 4, right? So let me write down here p of x is equal to x square minus 3x minus 4. Now I'm going to find out what is P of minus 1. Minus 1 square minus 3 into minus 1 minus 4 to 0. Yeah. So P of 4. What will be P of 4 then? 4 square minus 3 into 4 minus 4. That is equal to, again when we do it you will get 0. So which all are the zeros of the polynomial? Negative 1 and 4 for this particular polynomial x squared minus 3x minus 4. Now let's see some other which we have the cases. 3 cases are given here. You can see here. In this situation you can see that the parabola meets here at 2 points A and A dash in both the cases, right? So this may have the zeros of the polynomial too. This is how we can represent from a graph. How many places the graph met at x-axis? That's what exactly you have to check. Here in the second case, look at the figure. You can see that here it is meeting here. So only one point it is meeting, right? So here also the zeros of the polynomial only 1, okay? Now let's see for the third case. This is for the quadratic equation, these 3 cases. So here you can see it is not at all meeting anywhere in the x-axis, right? One graph is like this, one is like this. Our x-axis is here, for this is here, right? So nowhere it is meeting, and we can say that there will be 0, what? 0 zeros in this case. So what can we conclude? We can conclude that the geometrical representation, a quadratic polynomial, can either have 2 distinct zeros or 2 equal zeros or no zeros. In the second case, we have seen that there are here case 2 points it is meeting, right? So in the third case there is no zeros. So that is why we can say that for a polynomial with a degree 2 it has at most 2 zeros. It can have only 1 zero, no zeros, or 2 equal zeros, anything, but not more than 2. That is what it meant. Okay, so at most 2 zeros can have for a quadratic polynomial. Is it clear? Yes. So let's move on to the cubic polynomial. So in cubic polynomial, consider this polynomial x cubed minus 4x. So when we plot this related to this tabular column, you can see here how the graph is. So wherever it is meeting on the x-axis, we have to check. You can see here, then here and here. 3 places it is meeting, right? So let's see how it will be. So consider this cubic polynomials x cube and another one is x cube minus x square. So this graph is for x cube and this is for x cube minus x square. So in both cases you can see here only one place it is meeting, here 2 places. So what can we conclude for a cubic polynomial? Yes, for a cubic polynomial we can say that at most 3 zeros can have, right? There are at most 3 zeros for a cubic polynomial. So this is how we can understand from a graphical representation how many zeros that polynomial have. I hope it is clear for you. Thank you.